Hello everyone. So today we are going to talk about blockages and also tips for dealing with them and test cubes and to check the quality of your prints and a fidget spinner like no other fidget spinner. So, sooner or later anyone operating a 3D printer is going to have to deal with blocked nozzles. Today I will describe how to make fixing it easy for yourself and not something to dread and to defer. I will also show you a simple tweak to improve the print quality. Finally, I will talk about a print to demonstrate the capabilities of your 3D printer, a fidget spinner with a difference. So let's get started. Now, how do you know when you have a blockage? The first thing you see is under extrusion. I don't know if you can see this here, under extrusion, and the filament stops being extruded. So what I do is while the printer is still hot, I just pull out this tube, push down on the blue quick connect, and pull the tube out while it's still hot. And one of the main headaches of blocked nozzles is disturbing all the settings. So what I do is I make it easy to remove parts and not to disturb the settings. So you take off this fan, just so, you unscrew these two screws and you get the whole bracket with the sensor off, and also the other fan, and put it aside. You don't connect any wires. And this one, just undo that and undo this, and the nozzle drops out. Now once the nozzle is dropped out, you have to heat this hot end so that you can unscrew the cooling element. So I always have a spanner handy, and I go here, switch on the power, go into the controller, control temperature, nozzle, and I put the temperature to about 220. Back to control, back to main, back to the info screen, and you can see there now that the nozzle is starting to heat up to 220. So when it gets to 220, I just have my spanner on the nozzle like that, and use the other spanner to unscrew it. Because until it's up to temperature, it will be quite high. It will be quite tight. So you have this ready here, and you watch the temperature. It's 180, 186, 188, 190. It's already starting to unscrew. So the beauty of this is that you don't disturb any of the settings, and you don't disturb the heating element and the front nozzle, and you always tighten the back nozzle right up against the front nozzle, so the height remains the same and it doesn't disturb any of the settings. So once that's removed, I switch off the power, and while this is still hot, I take off this bit of extruded filament. And now it's easy to open out that hole. I'll have to clean it with, I have a tool handy, put in there, and I can feel it a bit hard. And if you can't do that, you'll have to drill it out. Well, it goes through, see, but it's still a bit tight. So I'll have to drill that out, and I'll come back, because there's still filament coating the inside of this. That's just the same diameter as the filament. So it needs to be cleaned out so that it's absolutely free. So I'll clean that and I'll come back. So now this is, I have a drill here, a portable drill, and I just put it in the hole and drill out and make sure that any filament sticking to the sides of the wall is cleaned out, and check that the filament is free to go through. You see the filament is very free. So it's ready now to put back together, and just have to switch it on, bring it back to temperature and screw it back together. Control temperature, nozzle up to 200 degrees, 220, back to control, main, info screen. Now while it's heating up, I just get ready to screw it back together. It's about 150 and it's already started. The thread is started in. So you hold that and tighten it. Like so. Once you tighten it, you haven't disturbed any setting because the height is going to remain the same, and you don't have to worry about leveling, and it makes the whole process much simpler. So it's ready to put back. Switch it off because you don't need it hot anymore, and put it back together. Just one nut on the bottom. Get it started. And it's just got to tighten it all up and put it back together, and it's ready to go. You haven't disturb the settings or Z offset or anything. So I'll come back when I've finished. So all I've got to do is to tighten the two screws, and I haven't disturbed any of the settings. Because the sensor hasn't been removed, and the height of the nozzle is the same because I tighten it up right up against each other. And you can see the blue tack, which is plasticine sort of putty. It holds those two nuts in position, so you don't have to fiddle around with the nuts. So all I've got to do now is to put the filament back into the hole, and it's ready to go. So hello, I'm back again, and you can see I've put the hose back in there, and everything is ready to go. The sensor is still at the same height, nozzle at the same height, so I can go straight into print from SD and select my job, rear plate, and it's ready to go. Started to heat the bed. It goes up to 15, and then it will come down to sense the bed. The sensor will pick up the bed in the correct position, and nothing has been disturbed, and it makes the whole process so much easier and simpler. So now it started to heat the bed. I have the bed at 30 degrees, so it's 26, 27, and so here it is. Straight away, there's no having to fiddle around with Z offset and picking up the bed level and anything. You just start printing straight up. And I always reduce the speed to about 50 or 60% for the first layer. So while this is printing, I just want to talk about how you can improve your quality of your prints. This little thing which I talked about in my previous video is very helpful because I was able to tighten my belt. So now there's no movement on the x-axis, and I was able to also fix these rollers so there's no movement, and now the quality of the prints can be seen in these tubes. That is the before that little tweaking, and now you see the edges are much straighter. The X and Y and Z. So that's very helpful because all the cable ties would have been very difficult to remove and readjust all the time. But this makes it much easier to just readjust the belt whenever needed. And just see this job proceeding nicely. It's making the base for these this fidget spinner. Now I had to redo that because this one broke off. That post broke. So this fidget spinner, if you want details, it's in the link below. There's a very good video on how to create these helical herringbone gear wheels. Okay, so here we have it, a fidget spinner like no other. See? So this plate had to make several attempts to do it because the infill was not correct, and these posts used to break off. So the moral of the story is that it's not the printer, but it's the slicer settings that make a big difference to the part sometimes. So anyway, that's an example of the capability of the 3D printer to print gears. And of course these gears, they were printed at a 0.3 layer height, so they could be made much more finer, and you get a better quality tooth. But the principle is that you can print gears and make things that actually function. So thanks, bye.